Hey everyone, we're going to do a review for volume and surface area combined. The way I look at this is the word problems on your assessments are going to have similar three-dimensional shapes. So you need to be able to determine which ones, what you're solving for, what it's asking for. So what we're going to do in this one, and be mindful of the instructions, round to the nearest tenths place when needed. We're going to write, what's it asking us to find? So our problem, right? And I'm going to write this for the first one. And then our solution, our formula, and then solution at the bottom. Okay, so if you use this strategy, I think you should be in good shape. So number one says, Nan and Brandon each have a cylindrical canister of Pringles. Nan's cylinder has a diameter of 7 inches and a height of 13 inches. Brandon's cylinder has a diameter of 5 inches and a height of 20 inches. Whose cylinder has the larger total surface area? So we need to know cylinder is larger. Okay, we also need total surface area. Okay, so we're going to use the 2 pi RH plus 2 pi r squared formula, and then we're going to plug in our numbers, and then we're going to see which number is bigger. So for Nan, it's going to be 2 times pi. The radius for Nan's cylinder is 3.5 because it's half of 7. And the height is 13. And then that's going to be plus 2 pi 3.5 squared. So that's going to be Nan. Brandon, same formula, but it's going to be 2 pi 2.5 squared times 20. Oops, that's not right. 2 pi 2.5. So I'm doing this out of order. Plus 2 pi 2.5 times 20. So I just did the 2 pi r squared first for that one. So on the calculator, you're going to see this. So we'll have this here so we can visualize. You have 2 pi 3.5 times 13 plus 2 pi 5 squared. So Nan solution is going to be 362.8 or 9 if you round to the nearest tenth, right? Brandon's is going to be very similar, but we're just going to replace the numbers with 2.5, and then the height for this one is going to be 20. The radius on this one is 2.5. So Brandon's is going to be 353.4. Okay, so we can clearly see that Nan is the larger of the cylinders. Okay, on to the next one. An ice cream package is cone-shaped. It has a radius of 5.8 centimeters and a height of 15 centimeters. If the ice cream is filled to the top of the cone, how many cubic centimeters of ice cream will the cone hold? So also cone. Anytime we do cone and we do filled in cubic centimeters, our problem is going to be to find the volume. Okay, and then we know the formula is going to be 1/3 pi r squared times h, because volume is BH, but it's a third of a cylinder. So then what we're going to do is we're going to plug in our numbers. So our solution is going to be 1/3 times pi times our radius, which is 5.8, okay, squared, times your height, which is 15. Okay, so when we plug all that in our calculator, we will get 1/3 pi 5.8 squared times 15. And our volume, it can hold 528.4 cubic centimeters. That's how much ice cream it can hold. Okay, on to the next one. Jose measures the diameter of a basketball, okay, as 14 inches, so it's a basketball. If you've ever seen a basketball, you should know the shape of a basketball is something like this, but it's actually like a sphere, right? So that diameter inside is equal to 14. Okay? How many cubic inches can it hold? Once again, there's the word cubic, right? So cubic inches, our problem is volume of sphere. Okay? Our formula is 4 over 3 times pi, it's radius cubed. Our solution is going to be 4 over 3 times pi times, what's r? 7 cubed. So then we go ahead and use our handy-dandy calculator, and we'll control divide 4 over 3 times pi, okay, times our radius, which is 7 raised to the third power. Okay, so our volume, it can hold 1,436.8 cubic inches of air. Okay, so once again, if you take your time, look at what they're asking us to find, use the correct formula, plug in our numbers, and show what we're doing, it's going to be hard to make a mistake if we use this strategy. Okay, let's go to the next one. And this video, this review might take a couple of parts to go through, but I promise if you stick through, it'll be worth it because you'll get some more understanding about how to work through work. Okay. Number 4, Carson's friend brought him a chocolate bar at a carnival. The chocolate bar is shaped like a long triangular prism, as shown. The bar is completely covered. The word covered is important there, by cardboard packaging. Find the surface area of the bar to determine how many square units of the cardboard can be found was used. So, completely covered sounds like total surface area. So my problem is going to be total surface area of triangular prism. Formula for that is pH plus 2. So we need to find P, find H, we need to find B. Okay? Well, we know H, let's get that out the way. It's the space between our two bases, and our bases are triangles, so my H is 35. The base would be base times height. Okay, so 15 times 12. But it's a triangle, so we need to divide by 2. So that means B is 90. 2B is 180. Okay, so then our perimeter, it's an equilateral triangle because of 15, 15, and 15. So it's equilateral triangle, so that's 15 times 3, or perimeter is 45. So if I do pH plus 2B, that says 45 times 35 plus 2 times 90. If I do it like this in my calculator, I should get it correct. So 45 times 35, okay, and I'll do parentheses just so you can see, times 35 plus 2 times 90, and then push enter. My total surface area is going to be 1,755 millimeters squared. Okay, and I have my total surface area. So we're a fourth of the way through, and we're making good time on this. We'll do one more in this video, and then we'll make another. So then, let's do number 5, and maybe I'll do 2. Let's do number 5. Gracie likes to eat cereal for breakfast every morning. She eats from the same bowl every day, which has a diameter of 7 inches. It's a bowl, which means it's kind of a sphere. If she fills her bowl to the top, how many cubic inches of cereal does she eat? So cubic inches is volume. This bowl is half of a sphere. So our problem is volume for half of a sphere, which means formula is going to be 4/3 pi r cubed, all divided by 2. Okay, our radius is going to be half of the diameter, which is 7. So that means our formula is going to be 4/3 pi times 3.5 cubed, and then we divide that by 2. So let's control divide 4/3 pi 3.5 cubed. We get 179.59. That's for the full sphere. We divide by 2, and that gives us a total of 89.8. And that's going to be inches cubed or cubic inches for my volume of that bowl. Okay? All right, let's do one more, and then we'll do the next set of part 2. And this will probably be a 3-parter, but I think it'll be worth it if I do it in chunks like this, so you're not going to be watching like a 30-minute video. All right, so let's do number 7. We'll do the other 2 on another video. Find the volume of the cylinder-shaped grain storage tank at the right. Volume of the cylinder, right? So problem, volume of cylinder. But the most important part is terms of pi. So terms of pi. Our formula for this is BH, which is equal to pi r squared h. But in terms of pi means to multiply everything except for pi. So what we're going to do is we're going to find r, which r in this case is half of 10. So our solution will be 5 squared times 8, and pi is at the end. Okay, 5 squared is 25. 25 times 8 is going to be 200. So our solution is going to be 200 pi meters squared. Okay, so on this video, we have went through 6 problems, and we have determined that if we read the question, write what it's asking us to find, and then write the formula, plug in the values, we should be good to go. Okay. On the next video, we'll do 6 more or so, and then we'll go from there. Thanks for watching. If you have any questions, please like, subscribe, share, and write those questions. I'll do my best to get to them. Okay. Thanks.